Hey, I'm Steven, and I'm going to be going over the 2014 AP Calc BC FRQ number 5. When we first look at the problem, we see a graph. It looks like we might be solving for an area, or looking at arc lengths, or something of that sort. Now let's read the problem to test our prediction. The question starts by giving us some background on the graph that they just gave us. Let R be the shaded region bounded by the graph of y equals x times e to the x squared, the line y equals negative 2x, and the vertical line x equals 1, as shown in the figure above. Now that we know a little bit about the graph, we can start looking at the actual questions. The first question says, find the area of R. If we look back at the graph, the area of R is the area of the shaded region that they gave us. This shaded region lies in between the graphs of y equals x times e to the x squared and y equals negative 2x. Using our knowledge of calculus, we know that we can take the integral of those two lines from the endpoints and add them together to find the area of R. We would take the integral from 0 to 1 because that's the domain of x values given in this problem, and we would take the integral of the two lines given, x times e to the x squared and negative 2x, and we would subtract those areas, but because negative 2x is negative, we would be adding the area under that line, and then that would be how we find the area of R. If we were to write this all out, we would get the integral from 0 to 1 of x times e to the x squared minus negative 2x dx. If we want to simplify this, we can break it up into the two pieces of each line, and we can get the integral from 0 to 1 of x times e to the x squared dx plus integral from 0 to 1 of 2x dx. Now because we don't have a calculator, we have to hand do the antiderivatives and then plug in the values to find the integral. X times e to the x squared is a complicated integral, so we have to use u substitution to simplify it. We take u equals x squared, and du then equals 2x dx, and then we plug that back into our integral. Because there is no 2x present in the x times e to the x squared, we have to convert it to x dx instead, so we divide both sides by 2. Then we rewrite our integral as 1/2 integral from 0 to 1 of e to the u du plus integral from 0 to 1 of 2x dx. Carrying out this integral, we get 1/2 e to the u evaluated from 0 to 1 plus x squared evaluated from 0 to 1. Of course, what I forgot to mention earlier was that when you use u substitution, you have to also change the endpoints by plugging them in and evaluating for them. Of course, in this case, they stay the same because 1 squared is 1 and 0 squared is 0. This is a common mistake that many people make in similar problems, but we get lucky because in this case, changing the endpoints is something that is unnecessary because the endpoints stay the same. But it's good to show the work anyways. Finally, we plug in the values to find the actual value of the integral. We get e over 2 minus 1 over 2 plus 1 minus 0. This evaluates to e plus 1 over 2, which is your final answer for the area of R. Possible mistakes for this problem include adding the areas under each line instead of subtracting the second one, or incorrectly doing u substitution for the x times e to the x squared. Now let's move on to part B. Part B asks us to write, but not evaluate, an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line, y equals negative 2. This question is a throwback to the AP Calc AB revolution problems that we learned last year. What we remember from AB is that revolution problems involve adding up a bunch of circles that make up the volume of the revolved area. However, in this case, because we're not revolving around a horizontal line that's the base of the area, we have to think of the objects as donut shapes rather than as circles. This means that to find the volume, we have to add up all of the outside circles and then subtract all of the inside circles. We remember that an area of a circle is pi r squared. Pi is a constant, so we can move that outside while we think about the rest of the integral. Just so that we can stop visualizing it and start working with it, we can write it as volume equals pi integral from a to b of big R squared minus little r squared dx. This is essentially the same thing as saying volume equals integral from a to b of pi big R squared minus integral from a to b of pi little r squared. Now we just have to figure out what big R and little r are equal to with respect to x. Big R is the bigger radius, and it's equal to x times e to the x squared plus 2 because we're rotating around the line y equals negative 2. Little r is negative 2x plus 2. By substituting, we can find that the volume is equal to pi times the integral from 0 to 1, our endpoints, of x e to the x squared plus 2 squared minus negative 2x plus 2 squared dx. Because the question only asks for us to write the integral but not solve it, we can finish right here. Common mistakes for this problem would be rotating around the x-axis instead of y equals negative 2, or subtracting the 2 because it's negative, or even forgetting the pi and forgetting to square the radius. Finally, we can move on to part C. Part C asks us to write but not evaluate an expression involving one or more integrals that gives the perimeter of R. If we look back at the graph and the shaded region R, we can find that the perimeter of R is composed of 4 segments. The first segment is composed of the arc length from 0 to 1 of y equals x times e to the x squared. The second segment is composed of the arc length from 0 to 1 of y equals negative 2x. But people commonly miss the third and fourth segments. The third segment is the vertical line that goes from the endpoint of y equals x times e to the x squared and the point on the graph 1, 0. The fourth segment is the vertical line that goes from 1, 0 on the graph to the line y equals negative 2x. To find the perimeter, we just have to add the lengths of all these segments. We can find the arc length of y equals x times e to the x squared using the arc length formula from 0 to 1. We can find the arc length of y equals negative 2x by finding the arc length from 0 to 1 in the arc length formula. We can find the length of the third vertical segment by plugging in x equals 1 to the equation y equals x times e to the x squared. We can find the length of the fourth segment by plugging in 1 to the equation y equals negative 2x. The arc length formula is the integral from a to b of the square root of 1 plus dy over dx squared dx. We find that dy over dx of y equals x times e to the x squared is equal to 2x squared e to the x squared plus e to the x squared. When we plug in 1 to find the vertical segments of both of those pieces, we get that one of them is e and one of them is 2. And if we think about it, the bottom piece on the graph is actually a triangle, so we can use a squared plus b squared equals c squared to find the diagonal length. We know that the horizontal length is 1 because it's from 0 to 1. We know that the vertical length is 2 because we just found that. So by plugging it in, we can find that the diagonal length is square root of 5. Finally, we can write all of these pieces together. We get the integral from 0 to 1 of the square root of 1 plus 2x squared e to the x squared plus e to the x squared squared dx plus e plus 2 plus the square root of 5. Because the question doesn't ask for us to solve the integral, we can leave this as our answer. Like I mentioned earlier, common mistakes for this problem include forgetting those vertical segments or incorrectly plugging into the arc length formula. Now that I've expertly guided you through this problem, you are ready to succeed in the future. Thank you, and good night.